Well, hello everyone, and welcome back to yet another episode of AWS OnAir Data Dive. This is the show where we dive deep and get those data treasures for you. As always, my name is Aditya Samant. I am your host, coming to you live from Dallas, Texas. And as it happens, it seems like every other show we have a Texan for you, other than mine, myself, and we have one for you on this show as well, and we'll reveal that in a second. So, if you haven't following the show, you know that we talk about relational databases quite a bit on this show, and primarily we have been talking mostly about the open source databases like the MySQLs and MariaDBs and Postgres of the world. But today we're going to pivot a little bit, and we are going to talk about commercial databases, Oracle specifically. We'll talk about migration, some of the challenges, and what are the best practices about migrating really large databases. Of course, I'm not really an SME. I'm just here to make humorous comments, as you guys know. But our specialist SMEs, today we have Vishal and Joe from the specialist teams. I'm going to ask them to introduce themselves real quick, and so then we can get started. Vishal, let's start with you.
Hello, everyone. My name is Vishal Patil. I'm Oracle Specialist Solutions Architect with AWS, and I'm the other one who's from Dallas. And we are just hoping that the temperatures stay below 100, just like today, for rest of the season.
It's very unlikely, Vishal.
Yeah.
All right. Well, thank you. Welcome, Vishal. Joe.
Yeah, hi everyone. This is Jobin Joseph, but I go by Joe. I'm also a senior database specialist SA at AWS, focusing on Oracle database deployments and migrations. Joined AWS 3 years ago, total 20 plus years of experience with Oracle databases, and I'm currently located at Toronto, Canada. Thanks for joining us.
Excellent. All right. Well, we all know that our customers love RDS, right? The RDS platform gives a lot of automation, a lot of benefits, but it's not always easy to migrate some of the databases from on-premises to RDS. There's size concerns and, all sorts of different challenges. So Vishal, can you tell us a little bit about what are these challenges and what are we doing to kind of overcome them to help our customers?
Sure. AWS customers who are looking to migrate their critical Oracle database workloads to RDS Oracle specifically, which is a managed service for Oracle databases in AWS, they have to make some decisions while migrating the Oracle databases to RDS for Oracle. There are several migration methods which are available, and for the critical workloads which are running on Oracle databases, they need to think about one of the top challenge could be, how do I reduce the downtime for the migration itself? Right. So some of the factors which contribute to that decision is size of the database, and then the network bandwidth between AWS and customers' data center. Right. So as the size increases, and if you don't have, let's say if you don't have direct connect, if you don't have network bandwidth, it may take longer for you to do the migration. And there are several migration methods, as I mentioned earlier, which can, help you by having these considerations. You will make a decision which migration method to use. Other migration, other considerations I would say is, some migration methods may require you to have a certain license from the provider, right? So you want to think about that. The cost of the migration itself may depend on the migration method you choose. Then the skills, whether you have skills to use one of the migration methods or the migration method which is most suitable for your requirements. Do you have enough skills to perform that migration, right? And not just that, other thing to consider is, the target configuration, like, the RDS Oracle instance you are configuring. Does it meet your workload requirement? Not just the workload, but even the migration method which you are going to employ. It should help with the performance of the migration itself, right? So these are some of the considerations, not challenges, I would say, but the considerations with respect to migrations to RDS for Oracle.
Yeah, that makes sense. A lot of our customers don't want to see downtime or want to avoid downtime as much as possible, right? If you have an application that has to be up 24/7, doing a multi-day migration of databases where the database essentially stays down is basically a non-starter. And licensing is something that you talked about. We don't usually discuss licensing because we primarily talk about open source, but that's a very important factor, right? If you already have bought licenses, how do you deal with that? And I know, Vishal, you and Joe, you both of you gents kind of face with those questions every day. So, okay, so having said that, Joe, I know there are multiple methods to basically do the same thing, right? There's logical migrations and there are physical migrations. But I know we're talking about something very specific today. It's a physical form of migrations. Why don't you tell us about that?
Yeah, sure. So like Vishal mentioned, there are logical migration options as well as physical migration options to move your database to RDS Oracle. But if you talk to an Oracle DBA, their first preference will be to choose a physical migration because it's more reliable. And you don't have to deal with complex data type issues and feature compatibility issues, the validity of the database, data integrity checks, and things like that. So there are multiple physical migration options that you can consider when migrating Oracle databases, including Data Guard, RMAN full database backup restore, and transportable tablespaces. And because RDS is a fully managed service, you don't have an options to bring the full database copy into RDS. So Data Guard and full database restore using RMAN are not the options for migrating to RDS Oracle, but we want to talk about transportable tablespace, another exciting migration strategy, which is classified as a physical migration strategy. So I can talk more about that if this is the right time for that.
Yeah. Let's talk about it. Let's kind of understand what transportable tables mean. It may mean that you're picking up tables and putting it in RDS. That would be fantastic. So yeah, tell us more about it.
Yeah. So transportable tablespace is like a well-known physical migration strategy for Oracle databases, and it has been around for many years now. But we launched a transportable tablespace feature on RDS in June 2023 to ease the migration of large and critical databases to RDS Oracle. And at high level, like you said, what we do is we plug in application tablespaces from the source database to the target RDS Oracle instance. So we're not migrating the entire database, but we are migrating at tablespace level. And there are two highlights of the TTS implementation on RDS. First thing is it supports cross-platform or cross-Indian migration, and the feature is called XTTS, and X indicates cross-platform. So for example, you have a database that's running on IBM X, for example, that's a big NTN platform. With XTTS, you can migrate the database into RDS Oracle that's running on little NTN format. And another highlight is that it also supports...
Right, because we run it on Linux.
That is correct. Yes, exactly. Yeah. And another highlight is that it also supports migration using incremental backups. So that means most of the time in the migration process, your source database is going to remain available, accepting all the read-write transactions, and you need only a short downtime to finish the cutover activities. So probably it's a good idea to look at some of the migration flows, probably to better understand how things work. So I would like to quickly share my screen to show the workflow.
Yep.
All right, so hope you can see my screen. All good?
Yep.
All right, so assume we have a database running in the on-premises data center that we intend to migrate to AWS. And the target for the migration is RDS for Oracle. And we assume that there is required connectivity already established between the data center and the AWS region, either using AWS Direct Connect or VPN connection. We use Amazon EFS file system for staging the backups for the migration. And the benefit of using EFS is that it can be mounted at the same time on the target RDS instance as well as on the source database server, which means you don't have to move the files between multiple staging areas. As soon as the backup is completed, it's readily available for restore to the target environment. And there are other options.
And for the folks who may not know, EFS is elastic file storage, right? So you can mount it as a multi-attach in multiple environments. So I guess what we're saying is you mount it on premises where you take the backup, And you also mount the same file system in RDS. So as soon as the backup is done, it's right there available to you.
Exactly. Yeah. That's a good call out. And there are other options as well. Probably we can talk about other options in a while. But once we have the EFS file system mounted on the source and target, we start with the level 0 backup of the table spaces that we intend to migrate. And the way we back up the table spaces using RMAN is slightly different from a regular database backup because we use Oracle provided Perl scripts for transportable table space migration for taking this backup. And once the backup is completed, the backup pieces are in the EFS file system that's readily available on the RDS, and you can just run the API calls to do the restore process, which will automatically do the conversion as well if the source database, for example, is running in a big 88 format. And from then onwards, our objective is to make sure that the target database is as close as possible to the source database so that during the final cutover, we can reduce the downtime required. So what we do is we take incremental backups, probably on a daily basis, to make sure that the delta changes happening on the source database is backed up and restored into the target RDS instance. And for that, we use the same process, backup to EFS file system, and then restore to the RDS instance. So during the whole process, the database on the source side remains available. And now we come to the stage where we're ready to do the cutover. So what we do is we take a short downtime, convert the table space at the source to the convert the table spaces at the source to read-only mode. We take a final incremental backup to make sure that all the delta changes have been captured, and then we transfer that to the RDS side, restore them, and we will take an export dump of the metadata for the transportable table space so that all the metadata information about the table space itself and all of its objects is available for importing into the target RDS instance, which can be imported there to make sure that the metadata is plugged in into the target RDS instance. So that kind of completes the migration process. Now the table spaces can be made read-write. And it's always a good practice to take a manual snapshot of the instance prior to importing the metadata, just because in case the metadata import fails for any reason, we can always restore the snapshot and reattempt the metadata import just to fix any errors that you face, instead of having to start all over from the level 0 backup. Once the metadata import is completed, we can make the table spaces into read-write mode, and that kind of completes the application cutover activities.
Excellent. So fairly straightforward, at least to me, it looks like you take a full backup, then you take all the deltas, and eventually you roll forward everything, and you just have the downtime only for the part when you're rolling forward everything, and then do a switchover. Sounds great. Well, let's see a demo. Love to see a demo of this. I'm sure you have some demos prepared, right?
Yeah, absolutely. So let's look at the demo. We have broken down the demo into 4 phases. And in the first phase, we will verify the initial setup, complete the prerequisites at the source and target databases, look at what table space we want to migrate, what are the objects in that, and also the install and configure the Oracle provided XTT convert scripts. So let's dive straight into the demo. So before we get started, it's always a good practice to review the documentation, or it's available in the RDS user guide about how to use transportable table space feature in RDS. Even if you're an experienced user of transportable table space, it's always good to learn how things work in the RDS world, which is slightly different from the on-premises environment, because in RDS, you get a better managed experience. You don't have to deal with running Perl scripts or editing the files manually. Instead, you call wrapper APIs that will do the job for you, behind the scene. In addition to the Oracle documentation, there is also a TTS master document available in Oracle support document that also talks about a lot of best practices, non-issues, troubleshooting steps that will be really handy during the XTTS migration journey. And towards the end of the same document, Oracle has also made the TTS scripts available for customers to download. So we will be using the scripts for taking the backup of the source database during our demo. Now, let's review our source and target environment. For the purpose of this demo, we are using an Oracle database running on EC2 instance as the source environment that will represent our on-premises data center. So I will connect to the database and then verify the configuration of the database. I'll take a SysDB connection and then run some query against the dictionary to verify the configuration. So I look at the database character set. I can see it's a L32 UTF-8 on the database character set, and national character set is L16 UTF-16. It is important to look at this configuration because one of the requirements of TTS is that the target and the source database character set should be compatible. So using this information, when you provision the target instance, you can have a configuration matching the source database configuration. And it's also important to look at the time zone version file, which is 42 for my source database. And one of the requirements for TTS is that you should have a matching time zone version file in the source and target environment. So I'll be using this information to provision the RDS instance. So for the purpose of this demo, I already have the RDS instance provision. So I'll use the instance called XTTS demo target, which you can see on my console. And if you look at the configuration of the instance, you can see it's a 19C database on January 2024 release update. The character set is L32 UTF-8, exactly matching the source database. I'll connect to the target database to see some of the configuration on the database layer. So I grab the database connectivity endpoint URL, then I'll use the PuTTY session to connect to the database. So the screen you see with the black background on the right side, that is my target environment, and the one on the left with the white background is my source database. So I'm going to run the same queries just to verify that configuration is matching between the source and target, and I can see that they're exactly matching. Now, as the next step, I'll look at the target source database to look at the table spaces available and decide which table spaces I want to migrate. So among these table spaces, I will choose TTS DB1 and TB2, which are the application table spaces holding my schema objects for this migration. And one of the requirements for TTS is that this table space set should be self-contained. And what it means is that no objects in that table space set should have a dependency on objects that's sitting outside the table space set. So for example, if you take a table that's sitting on table space 1, which has an index associated, which is sitting on table space 2, for that set to be self-contained, we need to include both of these table spaces in the migration set. So how do you verify? Yeah. And how do you verify that, whether the table space set that you choose is self-contained? And Oracle has provided an API call that you can run against the database, passing the table space names as an argument, and it will populate, a dictionary view if there are any violations. And in my case, there are no violations, indicating that we are good to go with these table spaces for migration.
Well, this is really cool because I know there are lots of customers who are wanting to move, from on-premises or from self-hosted, etc., that may have consolidated applications, right? So you have lots of applications that are pointing to the same database. For some reason, you want to peel those applications out because you don't want to migrate everything at the same time, right? You want to migrate everything slowly in batches. So this looks like if we architect it correctly, then you can easily just take the set of the tables that are belonging to a certain application, move it, and then have batches created like that.
Absolutely. And we have seen, like in the consolidated environment, we have seen customers doing that, multiple applications hosted on the same database across multiple table spaces and schemas, and they migrate in batches. They take individual application-specific table spaces in one batch, migrate them successfully, and then proceed to look at the second batch. We have seen such approaches taken by customers. All right, so let's look at the contents of the table spaces so that we want to migrate. So the application user is test_TTS, and I have 3 objects here, one index, one table, and a view. The index and table, as you know, these are segment objects. They have physical existence in the table space that we are migrating. And the view is a code object. It doesn't have a physical segment on the table spaces, but the code is sitting in the system table space. So we will see how the migration strategy will take care of both the segments as well as the code object in the migration journey. I also want to quickly look at the contents of the table. So I just have two records indicating, my name and Vishal's name, and we will add more records to the table as we progress through various phases of the migration journey, just to make sure that whatever ongoing transactions are automatically taken care during the migration process. And for the migrations itself, for staging the backup, and we discussed about EFS file system. So I have an EFS file system that is mounted on the source database server that you can see the file system ID you can see here, and is mounted on the mount point /EFS. And on the target RDS instance as well, if I look at the configuration, I can see it is using a specific option group that has EFS has been added as an option. So if you go down to the option details, you get EFS integration, and it has the same EFS file system ID as we saw on the source database mount details. So this confirms that the same file system is available as mounted on both source and target RDS instance. One final step to make the EFS file system available to the target RDS instance is just to create a directory object pointing to the EFS file system. So we use an RDS admin utility for that. So this creates a directory object in the database called XTTS EFS, and that points to the EFS file system that we create. So we can list the contents of the directory, and it will be empty except the directory structure because we don't have any files here. One last step in the preparation step is to look at the scripts itself, right? So I was showing you the Oracle provided TTS scripts that is available for download. So for the purpose of this demo, I have already kept them downloaded under the scripts directory in the EFS folder. And we can see there are multiple files available. This is the zip file we downloaded. When you extract it, you get many other files. But what is the most important is the properties file that you can see, and the Perl script that we'll be using for the backup itself. With this files downloaded and all the initial setup is completed and prerequisites have been verified, we are ready to start our backup process.
Excellent. All right. Well, actually, there's a very good question in comments, and the question is, well, why are we using EFS? What other methodologies are possible? Can we use S3 instead? I think that's a good question. Vishal, do you want to talk about that?
We can definitely use S3. In fact, S3 integration was the only option until late 2022, second half of 2022, when we announced RDS EFS integration, RDS Oracle EFS integration. But until then, it was S3 integration, which was, coming to the rescue for transferring files. Now, why we are recommending EFS, and you said it earlier that, you don't have to copy files to it or then download files from it. Since we are able to mount the EFS file system on both source as well as on target RDS Oracle through RDS EFS integration, we avoid those extra steps of copying and downloading, as well as the amount of time it takes, right, to do those operations. And that's why we recommend EFS basically.
It's probably faster. I don't know. Is it any faster?
Yeah, I mean, EFS, since it's like NFS share, S3, you can transfer files to S3, download from S3. It all depends on the network bandwidth you have between your data center and AWS, right? And that was one of the consideration we talked about earlier.
Yeah.
Now, other benefits of EFS could be you are saving on space. You don't have to allocate extra space on your source system, as well as you don't have to allocate extra space on RDS Oracle.
Yeah.
And I think most of us know that RDS Oracle, we cannot downscale the storage. Once we allocate storage to RDS Oracle instance, that storage will be available for you to use for future growth, but you cannot downscale. You cannot
shrink it. Yeah.
You cannot shrink it. Yeah. So, and some customers may have restrictions. We are suggesting EFS as the recommended option, right? So some customers may have some reasons for not able to mount the EFS on the source, right? In that case, we have seen, or we have helped customers to use the DBMS file transfer method, where they can transfer the files directly from their source to the directory object, which is on EFS in the RDS Oracle.
Yeah, that makes sense. I mean, different options are available. There are pros and cons, and there are trade-offs of speed and size and cost. So depending on the workload and the cost of not doing something, you can choose what works for you. So okay, that makes sense. I guess we should move on and see that next step of demo, that full backup. I think
Exactly.
you're gonna do that demo for us, Vishal. Maybe we can
Yes,
get your screen up.
I would like to share my screen. Okay. All right.
Right.
So what we have done and what Joe has done basically on the same source Oracle database and the RDS Oracle instances, he's completed the initial setup phase, right? So prerequisites, identifying table spaces to migrate and installing the XTT convert scripts. So now we are going to jump into the next phase of the migration, which is prepare phase. So what we are going to do is we are going to take a full RMAN backup, which is level 0 RMAN backup, and we are going to restore and convert, we say, because it could be cross-platform. In our case, it is Linux to Linux, so there is no conversion involved. But this would be, these are the only two steps we are going to do in this particular phase. So let's jump into the demo. Let me share my client machine.
Same as before. Left source, right destination.
We tried to match it. We thought, it is important to match what we are showing. So source is on the left with white background and target is on right with black background. So let's look at the XTT properties file. I'm stripping the comments and empty lines just to show what is important in that file. Table spaces, the table spaces which we are planning to migrate, the source platform ID, as this method supports the cross-platform migration. We are suggesting what is the backup location. We are also suggesting, use RMAN transport method, which is, we are not using image copies because we want to reduce on the amount of space taken by the backup so that, it doesn't use the unused blocks in the backups, right? That's what we are doing as part of this configuration. All right, let's take full backup now. We are already in the scripts directory. This is where all the files are kept. And now we are going to use the Perl script, which we used earlier, which we saw earlier. Joe showed that to you earlier. We are setting the temp directory. We are already in the scripts directory. Now let's take the full backup. Okay, the backup is, we are just saying Perl xtt driver.perl script, and we are saying -- backup. And you'll see this command repeating every time we are taking backup. We are not specifying if it's a level 0 backup or it's a level 1 incremental backup. The script itself will figure out what type of backup it is. And since we have very small table spaces, it completes the level 0 backup immediately. Now, one of the important step is, what we have done as part of when Joe created the directory object, he pointed that directory object to xtts_scratch location where the backups are kept. So our RDS Oracle instance should now have access to all the backup files, right? One thing it doesn't have access to is the metadata information of that backup, which is in the res.txt files, and that gets created in the temporary location. So we are going to copy that file over to xtts_scratch. And let's take a look at that res.txt file while we are here. So this is the metadata information I was talking about. And this should be available to RDS Oracle instance while restoring, because this is how it figures out that, what type of backup it is and, where to restore and all that, what kind of table spaces are those. One more important step is the changing the permission on the backup files and the res.txt so that the OS user on the RDS Oracle side should be able to access the files which are created, right? So because on the source, you may have Oracle user or some other user creating these backup files, whatever installation user you are using on the source. But on the RDS side, whatever Oracle user is there should be able to access these files. And that's why we are giving permissions to xtts_scratch. All right, so now we have the level 0 RMAN backup on EFS file system. We don't have to copy or anything. We just have to connect to our RDS Oracle instance and what we need to do is restore and convert, right? So I'm connecting to the same RDS Oracle instance which Joe was showing, and I will complete the restore piece of it, right? So this is the command. I'm just going to copy and paste. So it says that if you see the command here itself is like, calling from the RDS admin schema. And we have package, which is RDS admin transport utility, which are kind of, wrapper around the scripts provided by Oracle. We have created those wrapper packages and procedures. Import XTTS tablespace will, the restore the TTS underscore TB1 and TB2 backups, which are available in the XTTS EFS directory object. And this is the source platform ID, which is 13 for Linux.
Yeah. Okay.
And we can quickly check the status of the operation, because we want to make sure that it is not failed, right?
Yeah.
We want to see it being completed successfully. So it shows completed. And since, as I said earlier, table spaces are small, it's not taking a lot of time to restore or backup.
Awesome. So out of the 4 steps, we're done with 2 steps. And we're going to continue down this path, but I want to remind everyone watching the show, please take our surveys. Let us know what we're doing, how we're doing, if there is any additional specific topics you're interested in. And good news, first 50 people will get $20 in the AWS credits. So if you wanted to test out or create some small apps and test out AWS functionality, you can do that. So please rush and take those surveys so you're one of the first 50 folks. All right. So after that little plug, let's get back to our remaining part of the demo. So as I was saying before, right? Like, sure, it took only minutes for us to take this backup. But in real world scenarios where you have gigabytes or terabytes, multi-digit terabyte databases, this may take hours or even days to finish, right? Now, if you were to do it without any sort of deltas, that means the amount of time it takes for you to back up and then copy and to restore, you're essentially taking a downtime for your application, and that's definitely not desired. So what can we do here to reduce that downtime?
Sure. You said it right. I mean, in the real world scenario, we may have terabytes worth of databases, right? And to back up those databases, restoring those databases may take hours, if not days, into RDS Oracle instance, right? So to avoid that kind of downtime when you are doing the cutover, when you are taking the final backup and doing the cutover for the database, what we can do is we can take frequent incremental backups in between. So you take level 0 backup, which is your full backup, and that might take very long time. So you have to decide when to take that level 0 backup, right? So it should be well in advance to your cutover date, right? So you cannot, if you're doing cutover today, you cannot start doing full backup now, right? So you need to plan that accordingly. And then decide to have incremental backups, like, maybe every day, as Joe was saying, or you can maybe for databases which have a lot of changes going on, you can decide to have them like every 12 hours or maybe 6 hours. It depends on, what kind of change is happening on your database. The reason for doing multiple incremental backups in between is to reduce the amount of time for your final backup, right? Final backup, Joe mentioned that final backup requires downtime, where you will put your source table spaces in read-only mode, and then you take the final backup. And you want to, reduce that time as much as possible so that, the cutover time for application is minimal.
Yeah, makes sense. So I guess that's the next step of our demo, right?
Yeah, let's
do that.
Yeah, let's see that. And then, what we can do is just to generate some data before we take another incremental backup. I'm going to connect to the source database. Well, if I can type properly. Okay. Now we are going to add one more record, and this time I don't want Aditya to feel left out, right? So,
all right.
Yeah,
I'm one of the Oracle people now.
Yes, you are in Oracle database now. And then what we are going to, we inserted one record. We are not going to do a lot of things. Next is, we are going to take another incremental backup, not another. This would be our first incremental backup for the source database.
First backup. First
Yes.
incremental.
First incremental, yeah. So I'll show you the command I'm going to use for that incremental backup. And you will realize that we are not making any change to the command itself. So it recognizes that this would be incremental backup because it already finds the full backup and that information in the rest.txt file, right?
Now, is that based on the files that already exist?
Exactly.
Okay.
So we take the incremental backup and it determines that, okay, this is incremental backup. These are small table spaces again. So it took less time. Again, the rest.txt file, the new rest.txt file is generated in XTTS temp. To make it available to RDS Oracle instance, we are copying it to XTTS scratch location. Also, we are changing the permission on the files so that RDS Oracle can, read those files.
Yeah, gotta grant those permissions.
Exactly. And then, I was saying that the metadata information should get updated and show that, we have incremental backups now. So earlier we had only these 2 records. Now we have 2 more records, right? So one each for the table space 1 and table space 2, right? And it indicates that this is the incremental backup. Now we have all these files available on EFS now, and these are accessible to our RDS Oracle instance. So we should be able to, go to RDS Oracle instance, restore these new incremental backups. And what the script does internally is roll forwards the existing level 0 backup with this level 1 incremental backup. So we'll quickly see that. I'm going to run the same commands which I had earlier. Even here, the command is not changing. We are running the same RDS admin util package import XTTS table space. We are specifying TTS1, TTS-TB1 and TTS-TB2 as the table spaces. And this is the directory object and platform ID. So we are not changing anything with respect to the command itself. Now let's check the status again, right? We want to see it being successful, completed. Right, so it shows completed. This was from earlier, and this is the latest record. One of the things, in real world, it may happen that you have very large backups, and it may take some time to restore these, right? So that's what your question was, Aditya, earlier. And then we want to check the status of these backups, right? So this is one way of checking it. There is a log file which gets generated. We can look into the log file, or we can look at the $v session log ops kind of views to find out what operation is running, how much is left, and all those things can help us find out.
Okay. So does that conclude this step?
Exactly. So what we have done right now is we took the level 0 RMAN backup. We did that restore and convert, right? We completed that, and we did one roll forward with your record in the database now, and we did that incremental backup and roll forward at the RDS Oracle instance. Now we are left with the final stage of the transportable table space migration.
Yeah. So step 4 is basically going to catch everything up and put a bow on it. But before we get there, before we see that final step, Joe, are there any best practices that you can think of during this migration?
Yeah, so I'm going to talk about the best practices along the way, talking about the steps involved in the final step as well. So as we highlighted, we completed 3 steps in the migration process. The highlight of these steps is that the source database still remains available. We took full backup, we took incremental backup, but the database still remains available. The table spaces are still in read-write mode, accepting all the read-write transactions. Now we are ready for the final phase of the migration, and that's I hope you can see my screen. Just want to make sure that.
I think we're gonna have to swap your screen in.
It's fine.
There we go.
Oh, good. Okay. All right. So the last phase has mainly three steps involved. The first step is taking a final incremental backup of the table spaces and then restore to the target instance. Now, because this is a final incremental prior to the cutover, we need to make sure that no rewrite transactions happen to the table space after this phase. So we convert the table spaces into read-only mode. And so this is kind of a starting point of the downtime involved in the migration. And because we are converting the table spaces into read-only mode, the read-only queries can still be served. So if your application has read-only modules, they can still continue to function while we go through the final phase of the migration. So that was step number one. In the second step, we will do an export of the metadata of the table spaces and its objects from the source database and then import that into the target database. And the importance of doing that is that so far we have been restoring the database files into the RDS instance, as Vishal was showing in the demo, but these are not part of the dictionary of the target RDS instance. So by doing that metadata export and import, what we're doing is that the files which are already part of the RDS instance storage, we are plugging those data files and its related object metadata information into the dictionary of the target RDS instance. So that's the second step in the final phase. And once that is completed, we are ready to convert the table spaces back into read-write mode and then complete the application cutover. So these are kind of three mandatory steps in the final phase of the migration.
Makes sense.
So I can move to the demo just to walk you through the final steps in the conversion process, in the migration process.
Yeah, let's see the demo.
Yeah, all right, let me share my screen. All right. All right, I'm in the right screen. So I'm in source database. I'm connecting to the database and making a transaction to kind of represent the last transaction happening in the source database prior to the cutover. So I'll insert a record to the table that we have been using so far. I'll use the name of Colleen, who is one of the producers of the show behind the scene. So she's part of the migration journey. So this kind of indicating the last transaction happening from the application prior to the cutover. And once the cutover is completed, we will check that all these records inserted into the tables are available in the target database. Now, we are ready to make the table spaces into read-only mode. So we run the command alter table space read-only for both the table spaces.
So the downtime starts right now, right? As soon as we make it read-only.
Exactly. This is the beginning of the downtime.
Well, partial downtime. You can still read.
Exactly. Yeah, that is correct. Okay, now I'm going ahead and taking the final incremental backup of the database so that all the delta changes happen, including the final transaction I inserted to the table, is captured, backed up, and restored to the target instance. So I'll run the same backup command that Vishal has been using so far. There's no changes required. So there is no difference in the backup command. The only thing is that it will show an information message saying that the table spaces are in read-only mode. And that's just for information, so that's absolutely fine. And we will do the same steps. We will look at we will give the permission to the rest.txt and remaining file to the RDS instance so that it can read the file for the restore purpose. We will also take a look at prior to that, I need to copy the files, the rest.txt to the scratch area, and then change the permission. And we will also take a look at the contents of the rest.txt to make sure that it has entries available for the final incremental backup that we have taken. And I can see 2 entries for each table spaces. All right, so we have completed one step, which is the final incremental backup. The next step is creating the metadata export of the table spaces that we are transporting. And we will use an existing directory in the database, which is pointing to the same EFS folder so that the export dump can be imported to the target database. Let me take a look at the directory object. So there is a directory called data pump directory that is pointing to the same scratch location. And once with the directory already existing, I will run the export command to take the export of the metadata, transportable tablespace metadata for the tablespaces. So a standard expdb command, just that we're using some specific parameters to indicate that this is a transportable tablespace metadata export, and we mention the tablespace names to be included in the metadata export. And do the export as SysDBA user, and it should not take more than a couple of seconds for the export to complete. And there we go. And I'll change the permission of the export dump so that the instance can access the export dump on the target side. Now we have completed the activities on the source side for the final phase of the migration, and I'm ready to go to the target side to complete the activities there. So I'll just make sure that we can see all the files that we created, including the final backup and the export dump for the TTS metadata export. So I can see all the files are required, and we are ready to first we are ready to restore the final incremental backup that we have taken. So I'll use the same commands that we have been using so far. So that initiates the restore process, and I'll look at the XTTS operation view to make sure that it is completed before I move to the next phase. Yes, I can see. So there are 3 entries, one for the level 0 backup, and for the incremental backup, and the final incremental backup. Now, at this stage, I'm ready to import the metadata of the transportable tablespace, which we have exported from the source database. Prior to importing the metadata, we need to create the users which owns the objects included in the metadata export. In our case, it is just one user called test underscore TTS, and I have created the user. Now I will proceed to import the metadata. So to import the metadata, we will call another RDS admin transport utility API call, but this time the function name is import xdt metadata. And as a parameter, we will mention the dump file and the location, the directory object where the dump file exists. And that triggers the metadata import process. And this is going to take approximately 2 minutes. So while we wait for this,
yeah, actually, that's a good interjection point, since it's going to take a couple of minutes. Sorry, I know you wanted to talk about something, but I think there's a good question here that we should address. So data is key 1 to 3. That's a nice name. It rhymes. Is asking, I have a question about handling large data volumes during the migration process using transportable table spaces. In the real world, we often deal with much larger data volumes, and I would appreciate any insights you can recommend here.
Yeah, so I'll take the question. So one of the benefits of using XTTS on RDS is that it supports incremental backup that we have been explaining so far. So regardless of the data volume, your downtime is under control because the downtime required is for the final incremental backup. So as long as you can keep the source and target database as close as possible, the downtime required is for the time taken for the final delta incremental backup. So it really is, the downtime required is not really dependent on the size of the source database. So that's one point. And if the concern is about transferring such huge amount of data between source and target, we have multiple options. We already discussed EFS, S3, or we can also benefit from Snow family of devices if the network between the on-premises data center and the AWS region is not big enough to copy big chunk of data.
Yeah, makes sense. Just to add to that, the final incremental backup, which requires the downtime, right? So if you have one more incremental backup before the final phase starts, which is as close as possible, then the delta is minimal during the restore phase, right? The final phase of the migration when the downtime is required. So you can plan in that way. So let's say if you have very active transactional database, then you can define strategy for the incremental backups. And then, taking a backup very close to your final stage as well can help reduce the downtime itself.
Yeah, that makes sense. And I think, this is still this is still going on. Maybe we should discuss limitations. I'm sure there are some limitations of transportable table spaces. I think I got that right.
Yeah, exactly. Yeah, I can take that question. So, like any other migration tool, TTS also comes with certain limitations and constraints. And we can classify them into two. One is the limitations from Oracle database transportable table space as a generic feature, which applies to any Oracle database migration using TTS. And examples are, you cannot plug in system undo or sysocs table spaces, or you cannot move any sys-on objects, or the character set limitation that we discussed earlier, or the time zone version file dependency. These are kind of limitations and constraints from the generic XTTS feature. Now, the other classification is the limitations from RDS implementation of XTTS, and some of which include, this target should be enterprise edition. We don't support plugging in table spaces to standard edition, and also the minimum version of the source database must be 12C, so up to 11G. You can 11.204. You cannot use XGTS as a migration strategy if the source database is less than 12C in version. And also the source operating system as Windows is not supported as of today. But these are the limitations as of today. But we are working on, based on the feedback collected from various customers' experience, we are improving and trying to lift these limitations, and hopefully sometimes later we will have a better experience of using STTS for large database migration where all these restrictions are lifted and removed.
Yeah, that makes sense. I guess we are done. Do we have any other steps to perform before the actual? So I guess we are done at this point, right? All the migration is done. That's only the application has to move now.
Yeah, so the basic mandatory steps into the migration is completed. But sometimes customers have this question: I've done big data migration. How do we ensure that the target database files are all healthy and consistent? So for that, we recommend running a validate command using RMAN utility for making sure that the data files are physically and logically consistent. So there's an API call that we can run. It's optional, but if your downtime permits to run it during the actual cutover, it's highly recommended to do that as well. In our case, it took only a couple of seconds to do that. So after this, I'm ready to convert the table spaces to read-write mode. That's kind of end of the downtime, because the table spaces have now been converted into the read-write mode. Applications can connect to it. So let's take a look at the table that we have been making transactions to during the various phases of the migration. And you can see that all the records that we had initially, as well as the records that we inserted during the incremental backup and just before the final incremental backup, they all have been captured and migrated to the target side as well. But we also had a view that was pointing to this table. It was a code object I highlighted. Now you can see that the table, the view does not exist in the target database because the view is not physically present in the same table space we migrated. So just to complete the migration of code object, we can take a structural export of the schema from the source database and then import that into the target database as well, just to make sure that we don't miss any code object. So I'll just run the export of that as well from the source database. And again, it should not take more than a couple of seconds. And once the export is completed, I give permission of the export down file into the RDS instance, just running the same command. And now we are ready to run the import utility for the structured import of the code objects. And I use DBMS data pump API for that. And I've just mentioned the parameters such as what's the dump file name and where exactly this exists. It's in the same directory object. And once the import is complete, you should be able to access the view. The import may take a couple of seconds, but it was quite fast in our case because we're talking about only few objects. And now I can access a view which was not accessible earlier. Now, that's kind of the last step in the migration process. So we have completed all the phases in the migration, and we can probably mark it as a successful migration using XTTS between the source Oracle database in on-premises and a target RDS Oracle instance.
Yeah, excellent. That was fantastic, folks. I mean, live demo, I don't think it gets any better than that. So, I mean, regardless of, like you said, right, regardless of the size of the original database, let's say this was multi-terabyte and the initial database backup took hours. As long as you're taking, like, I guess you could automate the whole thing, right? Because you're running the same commands, you could have an event-based pipeline where one event feeds the other, and you just have a loop that keeps catching up to the deltas or the incremental backups, and eventually just have a few minutes of downtime if you just tweak it and tune it right. That's a really good way of doing the migrations. Yeah, so great information, great demos. Thank you, folks. Anything you want to mention before we leave, folks? Allow them to go.
Yeah, just a quick thing. Always test your migration, right? So you are using this method, but test the migration. You want to have a copy of your production database. You want to check that everything works fine before you do it on production, right? So it's always recommended to do a test migration. Also, another thing which I can think of is have the fallback strategy, right? Let's say if you want to go back to your original database for whatever reasons, we haven't seen many such cases, but you want to have that fallback strategy as well. Now, our XTTS does not support the RDS Oracle as source, right? So you can use some logical replication like Golden Gate or AWS DMS and start capturing transaction just before you do the application cutover from your RDS Oracle instance into the source database, just in case if you need to fall back on your original database.
Excellent. All right. Well, I think we are at time. Folks, don't forget to take the survey. I should put the final survey plug here. Again, I know there are some promotional code issues. We're working to fix it. Yeah, first, there it is. First 50 folks will get $20 in AWS credits, and feel free to use as you will. Again, thank you so much, Vishal and Joe, for your time. Great show, great presentation, live demos, and they've worked all well, so I'm really, really glad. And everyone watching the show, thank you for tuning in. We are here every Thursday. Next Thursday, we have a show on GraphRag on Neptune on 8/29, same time. So please tune in, and thank you for joining. We'll see you next time.